Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to find the slope of a line, which is a topic that frequently appears in the Mathematics Knowledge subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. More specifically, I'm going to break this video down into two main parts. In the first part of this video, I'm going to give you a very broad overview of slope, and in the second part of this video, there are going to be 9 practice problems. In order to get the most from this video, I strongly encourage you to work out as many of those practice problems on your own as you can. That is to say, after I read a practice problem, you should pause the video, work out the problem on your own, and then resume playing the video to check your solution. In the description of this video, there are also going to be timestamps for each question. If you feel confident in your ability to find the slope of a line already, you're more than welcome to use those timestamps to skip ahead to the practice problems. If, however, you struggle with basic math, including basic algebra, then I strongly encourage you to watch this video from start to finish. As far as any formulas in today's video go, you have to memorize a lot of formulas to be successful on the ASVAB. In fact, if you go to my website, asvabapp.com, you can download a copy of my reference sheet. And those are all the formulas you really need to know to be successful on this test. If you go to my website and actually download a copy of that reference sheet, you'll see that the very first formula on the very first page is in regard to finding the slope of a line. So again, memorize those formulas from my reference sheet because you're not allowed to use a reference sheet or a calculator on the actual test. So all that being said, let's go ahead and get started with today's video. Before we discuss anything about slope, I want to put everything in today's video in the appropriate context. More specifically, I want to start today's video by discussing exactly what slope is in relation to a line. So more often than not, equations of lines are written in slope-intercept form. And as we can see, the slope-intercept form of a line is y equals mx plus b, where m refers to slope and b refers to the y-intercept. So in today's video, you're going to notice that I'm always going to associate m with slope. Okay, so that is the key takeaway here. Slope is just one part of the equation of a line, and it's always associated with the letter variable m. Now that we know we're working with an equation of a line, and slope is just one part of the equation of a line, let's take a closer look at slope. Slope refers to the steepness of a line, and in an xy coordinate system, it's the ratio of rise, that is the change in y coordinates, to run, that is the change in x coordinates, between 2 points on a line. The key thing you want to take away from that statement is this. In order to calculate slope, you need 2 points on the same line. And if you look to the right here, you can see we have one point here, it's called x1, y1, and another point here, it's called x2, y2. Once you identify 2 points on the same line, you can plug their values into this formula to calculate your slope. That is m equals y2 minus y1 over x2 minus x1. Again, you have to memorize this formula. In fact, as I said at the start of this video, this is the first formula on the first page of my reference sheet. So make sure you commit this to memory. And in short, that's all you need to know about slope. So with that said, let's go ahead and move on. In case it's helpful, I went ahead and wrote out these steps you can follow to find the slope of a line. Again, step 1 says find 2 points on a line. And as you may recall, those points are called x1, y1, x2, y2. Then you're going to plug the values of those 2 points into the slope equation. Again, that's m equals y2 minus y1 over x2 minus x1. And once you do that, you're going to simplify and solve. So just be mindful of this. If m is positive, that means the line increases from left to right. If m is negative, that means the line decreases from left to right. If m is 0, then you have a horizontal line. And let me just show you what I mean by m is 0. So let's say we plugged in the values of our points, and we're left with something like this. M equals 0 over 5. Well, you should know that uh, as long as 0 is in the numerator, this just reduces to 0. Again, 0 divided by 5 is 0. And in terms of slope, that tells you you have a horizontal line. All right. And D here says if m is undefined, then you have a vertical line. So let's say you plugged in the values of your 2 points into the slope equation, and you're left with something like this. M equals 5 over 0. You cannot have 0 in the denominator of a fraction because that makes the fraction undefined. And in terms of slope, when you have m undefined, that means you're working with a vertical line. And if it's helpful, let's take a look at each of those visually. All right, so let's take a look at a few graphs here to drive home the points I just made. Again, if you have a positive slope, that means your line rises from left to right. If you have a negative slope, that is m is negative, you can see that the line falls from left to right. If m turns out to be 0, that means you're working with a horizontal line. And if m is undefined, that is you have 0 in the denominator, that means you're working with a vertical line. Now that we have a better understanding of slope, let's go ahead and get started with the practice problems. Again, in total, there are going to be 9 practice problems. And at this point in the video, I strongly encourage you to start pausing the video, attempting to work out the problem on your own, and then resume playing the video to check your solution. If you want to watch me work out the first 3, that's perfectly fine. But again, there's only going to be 9 of these practice problems. So that said, let's take a look at A here. Our instructions say, in each case, find the slope of the line that contains the 2 given points. A says we have the point -3, 4, and -1, -2. All right, so the first thing I'm going to do is I'm going to label my points accordingly. Again, we always call the first point x1, y1, and we always call the second point x2, y2. And as a reminder, we're going to be plugging the values of those points into the slope formula, which is m equals y2 minus y1 over x2 minus x1. All right, let's go ahead and plug those things in. We can see that y2 is right here. It's -2, so y2 is -2 minus y1. y1's right here. It's 4 over x2. x2, it's right here. It's -1 minus x1. It's right here. It's -3. All right. -2 minus 4 is going to be -6. And let me go ahead and fix this right here. This says -1 minus -3. A minus minus always becomes a plus. So this is -1 plus 3, or you could read this as 3 minus 1, which is just 2. All right, let's keep working this out. -6 divided by 2 is going to be -3. Again, a negative divided by a positive is a negative. So the slope of the line between these 2 points is -3. That is to say, from left to right, this line would decrease. All right, so that's that one. Let's go ahead and move on to B here. Again, the first thing I'm going to do is label my points accordingly. Again, we know that this is going to be x1, this is going to be y1, this is going to be x2, and this is going to be y2. In addition, we should know that we're going to be plugging the values for each of those into the slope formula, which is m equals y2 minus y1 over x2 minus x1. All right, let's go ahead and do that. We can see that in this case, y2 is 7, so this becomes 7 minus y1, which is 7, over x2, which is 5, minus x1, which is negative 3. All right, let's work this out now. 7 minus 7 is 0. 5 minus negative 3, again, minus becomes plus. 5 plus 3 is 8. Again, we have 0 in the numerator. 0 divided by anything is going to be 0. All right, so the slope of this line is 0. And as I've mentioned twice in this video, when m is 0, that means you're working with a horizontal line. All right, so we're working with a horizontal line in this case. Let's go ahead and move on to C now. Again, I'm going to start by labeling my points accordingly. I know this is going to be x1, y1, and that's going to make this x2, y2. We're going to be plugging the values of those points into the slope formula, which is m equals y2 minus y1 over x2 minus x1. All right. Y2 we can see is right here. It's 8. So this is 8 minus y1, which is 5 over x2. It's right here, negative 3 minus x1. It's right there. It's negative 3. All right. Let's work this out. 8 minus 5 is 3. Again, double negative becomes plus. So this is negative 3 plus 3, which is 0. 3 divided by 0, you can't have 0 in the denominator, so this is undefined. And again, if the slope of a line is undefined, that means we're working with a vertical line. That is a line that goes straight up and down. All right, so now that I've done those 3 practice problems, let's go ahead and move on to the rest here. All right, so now that I've worked out some examples for you, I strongly encourage you, if you haven't done so already, to work out the rest of these on your own. And as you can see, our instructions are to find the slope of the line containing each pair of points. Number 1 says negative 2, 3, and 4, 5. Again, I'm going to start by labeling those accordingly. I know negative 2 is my x1, and 3 is my y1. I know 4 is my x2, and 5 is my y2. And of course, I'm going to be plugging the values of each of those into the slope formula, which is m equals y2 minus y1 over x2 minus x1. Again, y2 is right here, it's 5, so this becomes 5 minus y1, it's right here, it's 3, over x2, x2 is right there, it's 4, minus x1, it's right there, it's negative 2, so that's minus negative 2. Let's keep working this one out. 5 minus 3 is going to be 2, and we have a double negative here. Again, 4 minus negative 2 becomes 4 plus 2. 4 plus 2 is going to be 6. And as always, you need to reduce your fractions as much as possible, including when you're finding the slope of a line. So in this case, what we're going to do is divide 2 and 6 by a common factor of 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So the slope of this line is 1/3. All right, so that's that one. For number 2, we're given the points 1, 3, and 3, negative 5. So let's start by labeling their values accordingly. I know this is going to be x1, y1, and this is going to be x2, y2. And of course, we're going to be plugging those values into the slope equation, which is m equals y2 minus y1 over x2 minus x1. Of course, y2 is right here. It's negative 5, so this becomes negative 5 minus y1, which is 3, over x2, which is 3, minus x1, which is 1. All right, let's keep working this out. Negative 5 minus 3 is going to be negative 8. 3 minus 1 is 2. So this is negative 8 divided by 2, which is going to be negative 4. All right, so the slope of this line is negative 4. All right, so that's that one. For number 3, we're going to be finding the slope of a line between the points 5, 2 and negative 3, 2. Let's start by labeling our values. This is going to be x1, y1. This will be x2, y2. All right. Now that we've labeled our values, we should know that we're going to be plugging them into the slope equation, which is m equals y2 minus y1 over x2 minus x1. Let's plug those values in accordingly. We know y2 is right here. It's 2, so this is 2 minus y1, which is 2, over x2, which is negative 3, minus x1, which is 5. Let's keep working this out. We have 2 minus 2, which is 0, and then negative 3 minus 5, which is negative 8. Again, 0 divided by anything is 0. So the slope of this line is 0, which means that it is a horizontal line. All right, so that's that one. All right, so we're trying to find the slope given the points 1 over 8, 1, 4, and 1, 4, 1 half. So to start, let's go ahead and label the values of our points accordingly. Again, this is going to be x1, y1, and this is going to be x2, y2. Of course, we're going to be plugging those values into the slope equation, which is m equals y2 minus y1 over x2 minus x1. Let's go ahead and start plugging those in. Y2 is right here. It's 1 half. So this is 1 half minus y1. It's 1/4 over x2, which is 1/4, minus x1, which is 1/8. All right, so it wouldn't be one of my videos if I didn't include fractions in it. So here we go. As you can see, in both the numerator and denominator, we're subtracting fractions. In order to add or subtract fractions, they have to have common denominators. That is, the denominators of the fractions you're trying to subtract have to have the same bases or denominators. In this case, we have a denominator of 2 and 4, which aren't the same. And in this case, we have a denominator of 4 and 8, which aren't the same. So our strategy here is to either rewrite one or both of the fractions such that they have the same or common denominator. Let's get started by working with the numerator. We should see that our denominators are 2 and 4, and 2 and 4 have a common denominator of 4. So we're going to rewrite these fractions such that they have a denominator of 4. As it happens, 1/4 already has a denominator of 4, so we're just going to copy that one down as is. To write 2 as 4, though, we have to multiply it by 2, and we're also going to have to do that to its numerator. Again, 2 times 2 is 4, 2 times 1 is 2. All right, so let's do the same thing with 1/4 and 1/8. You should recognize that 4 and 8 have a common denominator of 8. And 1/8 already has a denominator of 8, so we'll just copy that one down as is. To write 4 as 8, though, we have to multiply it by 2, and we're also going to have to do that to its numerator. 2 times 4 is 8. 2 times 1 is 2. All right, now we can go ahead and proceed here. I'm going to work this off to the side so I can keep this nice and neat. We have 2 over 4 minus 1 over 4. When you subtract fractions, this becomes this. 2 minus 1 over 4. 2 minus 1 is 1, so that's 1 over 4. So 2 over 4 minus 1 over 4 is 1 over 4. And let's work this off to the side as well. We have 2/8 minus 1/8 Again, this becomes this, 2 minus 1 over 8. 2 minus 1 is 1 over 8. So this is 1 over 4 over 1 over 8. All right, so you might think we're done, but we're not, because when you divide fractions, you actually follow the algorithm keep, change, flip. All right, so we have 1 over 4 divided by 1 over 8. So we're going to follow the algorithm keep, change, flip. And that says keep the top fraction the same. So we're going to keep 1/4 the same. We're going to change from division, which this fraction bar indicates, to multiplication. And then we're going to flip this second fraction. So instead of being 1 over 8, it's going to be 8 over 1. And let's go ahead and work this out now. Now, when you multiply fractions, all you do is multiply straight across. So this becomes 1 times 8 over 4 times 1. 1 times 8 is 8. 4 times 1 is 4. 8 divided by 4 is 2. So the slope of the line that passes through these 2 points is 2. All right, so you will see fractions on the ASVAB. You may not see it when you're calculating slope for the test, but you will see them on the test. So make sure you can work with fractions. And then finally, we have 5 and -1 and 5 and 3. We're trying to find the slope of the line that passes through those 2 points. So to start, I'm going to label this x1, y1, x2, y2, and I know I'm going to be plugging those values into this formula. M equals y2 minus y1 over x2 minus x1. Again, y2 is right here, it's 3, so this is 3 minus y1, which is right here, it's -1 over x2, which is 5, minus x1, which is 5. Again, we have double negatives. 3 minus -1, so this becomes plus. 3 plus 1 is 4. Then we have 5 minus 5, which is 0. Whenever 0 is in the denominator, we know that our result is going to be undefined. And since the slope of the line that passes through these 2 points is undefined, we know we're working with a vertical line. All right, so that's that one. All right, so I included a pretty challenging bonus question that says this. Find y1 if the line through the points 6, y1, and 1, -5 has a slope of 2. Believe it or not, you have all the skills to solve this one on your own. So if you want, pause the video, attempt to work this one out on your own, and then resume playing the video to check your solution. You may very well see a similar question on the ASVAB, so make sure you can work out something like this. Not surprisingly, I'm going to start by labeling my points accordingly. Again, if this is y1, then I know this 6 is x1. Again, if it's helpful, you can just call this y1, y1, which means that this is x2 and this is y2. All right. And more often than not, we've been plugging these values into the slope equation, which is m equals y2 minus y1 over x2 minus x1. Well, in this case, we know what m is. Again, m always refers to slope, so we know m in this case is 2. So let's replace this m with 2. Y2 is right here, it's -5 minus y1. We don't know what that is, so we'll just leave it as y1 over x2. Again, x2 is right there, it's 1 minus x1, which is 6. All right, so all we really have to do is solve this equation for y1, and we'll have our answer. So let's work on doing that. First thing I'm going to do is work out this in the denominator here. This becomes 2 equals -5 minus y1 over 1 minus 6 is -5. All right, so to clear -5 from the denominator on this side, I'm going to multiply both sides by -5. This will cross out here, leaving you with just -5 minus y1 over there. And then we have negative 5 times 2, which is negative 10. All right, to get y1 by itself, let's add 5 to both sides. This crosses out here, leaving you with negative y1 on this side. Negative 10 plus 5 is negative 5. All right. And as you can see, this is negative y1. We just want y1. So what I'm going to have to do is I'm going to multiply this side by negative 1 because I know a negative times a negative is a positive. Therefore, I know negative y1 times negative 1 is just going to be y1. But that said, I have to do it to both sides of the equation. So this is negative 1 times negative 5, which is just 5. And as you can see, y1 equals 5. All right, so kind of a challenging algebra problem there. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. Prior to making this video, I looked around to see what other prominent YouTubers were doing in regard to teaching people how to find the slope of a line. And to my chagrin, most of them really just show you how to plug in values into the equation and then solve accordingly. They don't put anything in context, such as the fact when m is 0, you have a horizontal line, and when m is undefined, you have a vertical line. And beyond that, they never mention the fact that you can solve for a missing value in a coordinate if you're given the slope and everything else. So in that regard, I think my video is more comprehensive. If you want to help my channel out, please consider subscribing to it. But on that note, I'm going to go ahead and catch you loose. Konnichiwa.